Hi, today I'd like to discuss generating sine wave signal on STM32 using assembly code. Pointing to code, we're starting with definition of directives. Each register has an address and individual bits are shifted to its position so they can be used later in the code. In order to save computational power on processor, this sine wave table was generated. These are 12-bit values. Then in reset handler, we selecting peripherals we're gonna use, opening the bridges to the bus, system bus, and then we're setting up the pin A4. This is the range we're gonna use on the digital to analog converter. And further on, we're disabling wave function, and we're selecting software trigger. For now on, I'm still working on triggering a digital analog converter by a timer event, but I haven't got a success yet. Then we allowing interrupt, global interrupt in NVIC register, and this is timer setup. So the prescaler is 7 plus 1, which is 8, and 8 megahertz divide 8 is 1 megahertz, and we repeating by 1, so that's 1 megahertz clock. The infinite loop is looping empty, but I think I could learn how to bounce between functions and save the interrupt from all that code. But anyway, I got the results working, so I'm pretty excited about that. So this is where we come into interrupt when timer values overflow. We're checking the flag. If the flag is set, if it's not set, we keep looping. If it's set, we jump here and we clear the flag and we store it to make it effect. Then this code manipulates the registers to generate the waveform. So we're copying R5, which is our X value in degrees, into two registers, loading address of the array, of the sine wave array, and we're comparing our copied X value. We're comparing if it falls within the range, and depends what quadrant of the sinusoid is, we branch off. If not, we decrement. And then for the return value, we coming here where we shift through the table array, and we store the eventual value in register 5, and this is checked whether it's in bottom or top half. So we do positive or negative cycle. Well, the processor doesn't, the digital data, they don't know, we're not using negative values, so we're starting in the middle of 12 bits, so it would be 2047, 48. Anyway, so let's follow on the code. So this is where we load where we load our value from table into DAC data hold register, 12-bit register, which is right hand aligned. And once we have it there, then we shift it to, then we pulse it with software trigger, and this data is moved to data output register of a DAC. And eventually the copy of value in degrees is manipulated with accumulator. This little code steps through a 360-degree. Every interrupt just accumulates. And once we reach 360, goes to 0. And when we look at the wave which is generated, it's quite a achievement for getting through the code with the minimum knowledge and resources, and a few suggestions from colleagues and book. Thanks for watching.